Hello, this is Alex again, and in this video we will go over how to model only using the graphical area in RFEM. This relates to the previous two videos about modeling where we modeled only using the tables and only using dialog boxes. To start off, we will go up to New Model and we'll enter our model name. Everything in the dialog box is filled out correctly, so we'll hit OK. Now to start modeling only using the graphical area, we can go up to Insert, Model Data, Nodes, and we can select graphically. We'll put our first node at the origin, and we'll put our second node 10 feet away from the origin. Now we'll go up to this button called New Line. We'll click that, and we'll click the first node, and then we'll click the second node. Also, you can just type in, as you can see in the dialog box, the length is highlighted. So when you're working in the graphical area, you can just type in the length you would desire and you can hit enter. And you can see that a line was created with that length and the direction you have your mouse pointed to. We'll right click and then we'll right click again to cancel out. And we'll hit Control Z to get rid of that extra line. Now we have our two nodes in our line. We can go to materials. We have our material set, and then we can create our cross section and we can assign it to this line. Or an easier way to do this is just we can delete all this, and an easier way is to use the new single member button. We can create our member and we'll select our cross section. We will use an I-beam and a W shape. We'll just go with a 27 by 84 W shape. Now we have our W shape and our material set. As you can see, the material set within our cross section down here. We'll click OK. And now we can just start drawing our member within the graphical area. We'll have it start at the origin and end 10 feet away in the X direction. Now our member is created, we can assign nodal supports to it. We'll go up to the button called New Nodal Support and we will create a new one. For this nodal support, we want it to be fully fixed. So as you can see, it can't move in either global direction and it can't rotate about any global axes. So we'll click OK. We'll click OK again. And now in the graphical area, you can see we have a nodal support icon next to our mouse. And now we can select the first node. Now that we have our simple cantilever set up, we can go up to this button up here called New Load Case. We'll click on that, and then we'll create our first new load case, and we'll just call it dead load. We'll keep the self weight set, and we'll click OK. Now that we have our first load case created, as you can see up in this drop down, we can create our first new member load by using the new member load button up here. Now our new member load dialog box pops up. We can use a load type of force, and we'll use a load distribution of trapezoidal. We'll keep our load direction related to the true member length, and since we chose trapezoidal, you can see up here in the graphic how this trapezoidal load is displayed on the member. You can see a load of P1 starting off and a load of P2 ending, and that corresponds to the load parameters down here. We'll keep P1 as 0, and we want our uniform load to go up to a maximum load of negative 10 kips per feet. If you don't want the load to go the entire length of the member, you can turn this off, and we can customize where our load will be on the member using relative distance and percentages. We want our uniform load to start off at 10% of the distance away from the member start, and then we want it to end at the 100% distance away from the member start. So once that's set, we'll click OK, and then we will click on our member, and as you can see, our load was added to the member. Now that we have our nodal support, member, cross section, material, and load case and load applied to our member, we can go up to the button up here called Show Results. Or we can also click the Calculate All button, and this will run our calculations, and the analysis for our calculations has appeared in the graphical area, showing our member deformation as 0.216 inches. And we can also view our maximum moment about the y-axis, and also our maximum shear or shear diagram in the Z direction, and that comes up to 45.84 kips. I hope this video was helpful in learning how to model in the graphical area compared to our previous videos where we modeled in the table and modeled only using dialog boxes. In my opinion, I believe the graphical area modeling is a lot quicker and easier and can save a lot of time. In the next video, we'll go over specifically how to apply nodal loads and what that consists of. Thanks for watching.